Hey guys, it's Mr. Omura again. I'm going to show you how to do a Ken puzzle. These are wonderful little puzzles, and the best way to do them is really just to get in there and do them. So I went to the Ken website, and I'm going to do a 4x4, and that just means that all the values have to add up, or have to well, you'll see, and we'll do an easy one for now. So here's how you play. You take a look. And this says 2 divided, so take a look. This says 3 minus, so the two numbers that I put in these two boxes have to subtract to 3. So the only thing that it could be would be a 4 and a 1, so I'm going to use my little notes column. And that means that these two would have to be a 4 and a 1. This only has a 3 in it, so I'm going to put down 3. Which means this one has to be a 1 because it only has a 1 in it. But these two have to be subtracted 3, so they can only be a 4 and a 1. So I'm going to use my notes again, 4 and 1. Now, you'll notice something interesting kind of happened. When I put in my 1 here, this one now no longer can be a 1. It has to be the 4 because I can't have two 1s in the same row, nor can I have two 1s in the same column. So this has to be my 4. Which means this one has to be my 1. Well, logic would then tell you that this has to be a 2 and a 3, and this has to be a 2 and a 3. I don't know which one's which, but I do know that one of these has to be a 2, and one of these has to be a 3. However, if you think about this logically, what two numbers divide to 2? Well, it has to be a 4 divided by 2 or a 2 divided by 1. Well, I said that these two has to be a 3 and a 2, so that means that this must be my 2, which makes this my 3. Now, I don't know if this is going to be a 1. I don't know if this is going to be a 4. But let's see. If this wasn't a 4, that means that this one of these would have to be a 4. And 4 plus 3 is 7, which is too big. Which means that this must be my 4. Well, I already have a 1 here. So, this has to be my 2. And this has to be my 1. And that makes sense because I have a 1, 2, 3, and a 4. 1, 2, 3, 4. Oh, look at this. I have a 1, a 2, a 4. So this has to be my 3. Now, I had the 1 and the 4 here. I have a 1 here, so this must be my 4, which makes this my 1. Now I have a 1, a 3, and a 4, which makes this my 2. 3 times 2 is 6. 6 times 4 is 24. So let's say 1, 3, 4. This one has to be a 2. 1, 2, 4. This one has to be a 3, and 3 minus 2 is 1. So I went through that one pretty quick. Let's see if I can do one that's a little bit more challenging. What is going on? Alright, so this one might be a little bit more challenging. Here's my freebase, so it's going to be a 4. These 3 have to multiply to 2. Now, that's actually going to be pretty easy because the only numbers that multiply to 2 are 1 times 2, but I have to use 2 of them have to be the same. So this is going to have to be a 1, and this one has to be a 1, which means this has to be my 2. So that was actually pretty lucky. The problem is, this is going to be a 3 and a 4, and these are going to have to do something as well. These two have to add up to 4, and the only numbers that add up to 4 are 1 and 3 and 2 and 2, but I can't use 2 and 2. Well, I know this can't be my 1, so this has to be my 3, and this has to be my 1, which is nice because that means that this has to be my 2. Now remember, I said the only numbers that divide to 2 are 4 divided by 2 and 2 divided by 1. Well, this can't be the 1, so this has to be my 4. Alright, now, we're in a little bit of a pickle here. Oh, maybe not. I have a 1 and a 4, so I have a 3 and a 2 here. That makes sense because 3 minus 2 is 1. Well, there's my 2, so this can't be my 2. This has to be my 3. That has to be my 2. And now this all falls apart. 1, 2, 4. This has to be my 3. 1, 2, 3. This has to be my 4. That's good. I have a 3 and a 4 here, so this has to be a 1 and a 2. I have my 2 there, so this is going to be 1. This is going to be 2. 1, 2, 3. This has to be my 4. 1, 2, 4, and this has to be my 3. And that's it. Give these a try. Give them a shot.